Hello, let's continue our Sudoku adventure with Stonks by PjoeterBliep. This continues our same difference lines theme week. Hope you're enjoying it. So today we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. These thicker teal lines are same difference lines. Every adjacent pair of digits on the same line have the same difference between them. The difference is calculated with larger minus smaller. We don't go negative. So if this was 3, let's do 3, 2, then this has a difference of 1. So these two would need to have a difference of 1 as well. So we could go down to 1. And then these two would have a difference of 1. So we could go back up to 2 and then maybe to 3. So this would be one way to fill this. It's difference of 1, difference of 1, difference of 1, difference of 1. Right? Just bigger minus smaller. That's our difference. So it's different than sequence lines. All right, we also have these region sum lines in the grid. These are these much thinner blue lines. What we do is we segment them. You create a new segment whenever you cross a box boundary. And so this is a segment and this is a segment. Every segment on the same line has the same sum. So whatever these two add to, say 5, 6, that adds to 11. That would mean these 4 add to 11 as well. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I am going to start with this region sum line because the absolute minimum this could add to is 1, 2, 3, 4, which adds to 10. That's the absolute minimum. The absolute maximum this could add to is 5, 6, which is 11, meaning that we either add to 10 or 11. So we're either 4, 6, or 5, 6, meaning we always contain the 6. And then this is either 1, 2, 3, 4 or 1, 2, 3, 5, meaning the 6 is out here. And then we always contain 1, 2, and 3 here, if that's helpful at all. And that means that this is either going to be 4, 6 or 5, 6. And it's actually the opposite of this one. Because if we think about it, if this sums to 10 and the entire box sums to 21, because 1 through 6 is 21, then this has to add to 11. So if this is 10, and this is 11. So these are opposite. If this is 10, this is 11. If this is 11, this is 10. Now, that means the difference here is at most 2. If this was a 5, 6 pair, actually, can this ever be 6? No, this can't ever be 6, because if this was the 6, then this is 4 or 5. I don't even care which one. If it's a difference of 1 or difference of 2, we would need the same difference over here. And that would force these two digits to be the same thing because we can't go higher than 6. And so actually we can place the 6 in the box right here, and then this is down to the 4 or 5 that isn't on this line. I think at this point I don't need those corner marks because this tells us the same thing. And so now this actually does have to be the same as this. And that makes a 4, 5, 6 triple, making this from 1, 2, 3. Now, I think that does imply a jump here, because if we do 6, 5, we'd have to do 4 here, and that's not available. So we're going to do 6, 4, 2, and a 4 here. This is now a 5, 6, and this is, of course, 1, 2, 3, 5. It's not 2. These can't be the 5, so the 5 is one of these two. And this, of course, a difference of 2 doesn't go back up to 6, it goes down to 2. All right, so this is from 1, 3, 5. These are the evens. Yeah, I mean, when you have a difference of 2, it's either going to be all even or all odd. We've learned that plenty of times in this series. Now this is the sum of these two. So it's certainly not going to be a 1. If this is a 3, this has to be a 1, 2 pair. A 5 without a 4 would have to be a 2, 3 pair. So this always has the 2 in it. All right, this is just a pair. This is 1, 3. So that makes a 1, 2, 3 triple. This is 5 or 6. Now this, of course, can't be a 1 because it's the sum of these two. So that's a 1. This is 1 and 2 because this 2 here. This is a 1. All right. So we're going to be walking up from the 1. Oh, down here we get the 5, though. That's 3. That's 1. That's 2. Let's finish all that up. This is from 1, 4, 6. All right. So we know that the 1 and the 4 need to go up here. We're never going to repeat the 1, are we? No, I guess we could. We could do like 1, 4, 1, 4. That would be valuable. In fact, we're not going to 2 or 3, making our difference at least 3. And when our difference is 3, we can't go twice in the same direction. So we're always going to be bouncing back and forth between the same two digits, right? Because if we go from 1 to 4, that's the difference of 3. 4 can't go up to 7, so it's going to go back down to 1. And 1, of course, can't go down further, so it's going to go back up to 4. So I know that this is going to be a 1. But I know these two are the same digit, but I don't know what that digit is. It's a 4, 5, or 6, though. This is also 4, 5, 6. All right. And these two are the same digit as each other. I'm just going to mark them green to remind myself of that. These two digits are just done. This is a 5, and this is a 6. And so this is a pair. This is a 3, 4 pair. All right. Do we have... Let's see. One's one of these two. I'm seeing if there's any Sudoku. Oh, this ended up 2, 3. So this is a 5. That's helpful. That's 3. That's 2 and 3. These are not 5s, which means that's not 5. That places the 5 here. We get the 6 and 5 here. All right. Already coming in handy. What do I need here? I do need a 5 in this box, which goes there. 5s are done. So this is 3, 4, 6. Okay, since these are the same digit as each other, this is not the same. Oh, this is also the green digit, I guess. This is the purple 4, 6. Ah, 4, 6 pair. So that's a 1. That's a 1. This is the purple 4, 6. This is now the 3. That's 4 and 3. And so the green 6s are 4, 6s are 6, and the purple 4, 6s are 4. We can get rid of the colors. And our last two digits are the 2 and the 4. That's 4, that's 2. All right. Oh, what just happened? I think I hit help. Okay, we're back. So a nice puzzle, PjoeterBliep. I enjoyed that. I think that was cool logic. And this sort of bouncing around that same difference lines have to do when they're 3 or higher has been useful over and over again in the series. All right, well, how'd you do?